Okay, welcome to the beginning of the second half of the summer curriculum for geometry. And what we have here today is even more about angles. Here's the difference between today, though, and the last couple weeks. We were dealing with triangles, so our shapes were closed. Now we are dealing with just angles in general, and angles that you may see sketched, and how angles relate to one another. That's kind of the main idea. If you didn't believe it, here's your angles are everywhere picture, just to sort of remind you that this is really applicable, and architecture is the easiest way to really see it. But acute, obtuse, and right are going to mean the same thing that they did for triangles. Acute's going to be an angle that is less than 90 degrees. Obtuse is greater than 90 degrees, and a right angle is equal to 90 degrees. So on this picture over here, I'll try to highlight it and maybe we can see it a little bit, but on this picture right here, an acute angle might be this one right here. Just the corner of that eave right there will have formed a pretty little acute angle, and you can probably see the right angles everywhere. I mean, there's a lot of right angles in construction, and the reason for that is because they are the most sound. They are sturdy and durable, and it's how things get pieced together. So you're going to see a lot of that. Now, an obtuse might be kind of tricky to find on this picture. And actually, I'm having a really hard time finding an obtuse. This up here might be obtuse, but it also might be a right. It's hard to tell, but that could be bigger than 90. So anyway, the main idea here is just remember how you did triangles, and that's going to hold true. Now, another thing that we're going to do besides classifying an angle, which that's what that is, that's classifying an angle, okay? The other thing we're going to do is start talking about specific types of angle relationships. And this is something that you did a long time ago, maybe 7th grade, and it's going to come back with a vengeance, okay? Complementary angles. If you don't remember, complementary angles are two angles whose sum is 90 degrees. So in other words, they make up a right angle, two angles that make up a right angle. So sometimes the picture might just be something like this, and you've got a little angle in here, and you're like, oh, that's 30 degrees. And so if it's drawn out all nice for you, and you know that they're supposed to be complementary, it's pretty easy to find the other one, because if they have to add up to 90 and one of them is 30, then how do you find the other angle? Well, you could just piece it together. You could just subtract this angle from this one, and you could get 60. So it's pretty easy if they're already numbered and labeled. What makes them kind of tricky is that sometimes you might be given a picture that looks more like that, where there's a bunch of angles crossing, but you know that they're crossing at a 90-degree angle, but somebody still might do the same thing to you, where they might divide this one up and say, okay, this is 25. And then they may ask you to find this one. So if the picture looks all weird, just really focus in on the fact that this is the right angle. So you know that they're supposed to add up to 90, and then you can figure out that this one is supposed to be 65? Does that make sense? Yeah, 65 works. Okay, so that's kind of how those work. Now, supplementary, if you forgot, same thing. It's not the same as this, but it's close. It's still two angles, but now you want the sum to not be 90, but supplementary, the sum is 180. Okay, two angles whose sum is 180. Now, that's weird because a lot of you only know about 180 as being a triangle. Like you're like, oh, that's what a triangle adds up to. Okay, you're absolutely right. But something else that adds up to 180 is a line. So yes, ladies and gentlemen, that's where that saying comes from, the whole, well, he turned a complete 180. So when people say that about other people in their life, they're talking about a drastic change in the completely opposite direction, because it is a straight line distance across. So that's 180. So your picture might look like this, where somebody draws a random angle in the middle and says, okay, so this one is 70, and then you have to find the other one. So it's the same idea as this. They have to add up to 180. So 180 minus that 70 will give you whatever the extra is supposed to be. This one can also be a more complicated picture if they give you something like this. And I have seen this before, something like that. And they give you like all these lines crisscrossing, and you're like, okay, what am I supposed to do with that? But then maybe they'll only tell you like, okay, this is 150. And they'll say this is X, and your job is to find X, okay, or to find the missing angle. So what you're supposed to do in a case like this is try to ignore everything except for the straight line that you see. If they're laying on a straight line, focus on that and try to ignore this, okay? And then you'll do it just like this one. So if this is 150 and the whole thing has to be 180, then you know that's 30, okay? So how does it get harder than this? Well, we incorporate algebra into this concept. So what you may see sometimes is a picture given like this. And then you may see like, I don't know, maybe this is labeled with an x plus 10, and then this is labeled as like 3x, okay? And you may be asked either to find x, or you may be asked to find the angles. You know, I'm not sure which thing your teacher will be more interested in, but you'll be asked for one or the other. And so you're supposed to look at this picture, know the relationship, and set up an equation to solve it. Okay, so it's very similar to that triangle 2 weeks ago, that triangle lesson that we have. You have to go, okay, well, here's a straight line. So a straight line is a linear pair, or it's supplementary. And what's true about a straight line? Well, it adds up to 180. So if it adds up to 180, you really do just get to write, okay, this one plus the other one, that's going to add up to 180. Okay, and then you just do algebra. So 3x plus x is 4x. Now we move the 10 to the other side. Is that a 170? Okay. And then we divide both sides by 4. Now 4 does not go into 170 evenly, but that's okay. We can leave our answer like this. If you want, you can divide both of these by 2, because 2 goes into both. So 2 goes into that. Is that 85 times? Okay, so it's 85 over 2. So this is your x. So if your teacher wanted x, then x equals 85 over 2, or 42.5 if you want the decimal. If your teacher wanted the actual angle, then keep in mind you would have to take this x and plug it in here and plug it in there and math that out, okay? Now, I'm saying on this lesson, feel free to use a calculator, though you'll run into a lot of decimals, and teachers are going to be okay with you using a calculator to plug stuff in, okay? All right, so what else is this lesson going to be about, right? Well, when you go to the next page, notation, okay? Notation is what comes next. Now, math teachers, especially geometry teachers, very, very picky about notation and how to label things. And I've seen students that have made, like if I've looked at their test, and they've had a 100 because they got all the math right, but they may have made like a 70 on the test because they missed their notation. So there's different ways to notate things, and that's what I want to show you, okay? If you have an angle, then you could see one of two things. Sometimes you will see a number in the middle of the angle, and if there's just a number hanging out there, then you just would call that angle 1, like that's just a 1, and so you could name it like that, okay? Now sometimes I have seen where there's points everywhere, okay? And we'll call this like BRD. It doesn't really matter. but you'll see three letters that also are lying on the angle, and sometimes you need to name the angle with those letters. Okay, now one way, the most basic way, is to just call it angle R, where you name the angle by its vertex. The vertex is of course the middle of the angle. Okay, so sometimes you can just call it, oh, that's angle R or angle 1. That would be really easy, right? But sometimes they also want you to name it with all three letters. And when you do that, you just have to make sure that that R is in the middle. So you could go BRD and keep that vertex angle in the middle. Or if you want to go backwards, you can do DRB. So with a lot of angles that are given, there's like 4 different ways to name them, and so that's going to be very important to know once you get into geometry. Okay, now what if there's an angle inside of an angle? Okay, so in other words, you might be given directions to sketch angle ABQ inside of angle ABR. Okay, so if you have to do a 3-letter angle inside of another 3-letter angle, I always start with the bigger one. So if this one's on the inside, then I go ahead and draw a big one and call it ABR. And you know, we don't know how big it is, but go ahead and label ABR. And once you've done that, then we can slide somebody on the inside of it. So we can sketch ABQ somewhere on the inside. Now it doesn't say where on the inside, so put the extra ray wherever you want. I'll just put it right there. And make sure that you do label it. So that Q that's there, we need to make it also be a point on our extra ray. So that would be an angle inside an angle and how they would be labeled. Okay? All right, now sketching an angle. So if you're told to sketch BDG equal to 90, well, most of you know by now that 90 looks like that, okay? But you need to label it correctly. So if you did, you have 2 choices. You could either do BDG this way, or if you did GDB, that is also correct, okay? Just make sure that D's in the middle here because D is in the middle here, okay? That's the only catch. All right, cool. So now that we've talked about labeling angles, oh, by the way, one more thing. You might see a little M in front of the angle side, so it might say like here, it could have said the measure of angle BDG is 90. That's all that it is. The measure of angle A is 30 degrees. It stands for measure. So if you see a little M, sometimes I've seen it, sometimes I don't see it. It depends on the teacher. But just in case you see it, that means measure. All right, cool. And the last one is just to pull it all together before you try the homework stuff. It's the challenge problem, okay? Given that ABF is a straight line, okay, so let's draw a straight line, and let's go ahead and call it ABF. So doesn't matter where your A and F are, but B better be in between them. There we go. So ABF is a straight line, and it's made up of angle ABC, which is 4x, and CBF, which is 5x. Find x and find the measure of each angle. Okay, so we need to be able to draw a picture correctly. If it's ABC, and that's a 4x, then you need to say, well, here's my A, here's my B, I need a C. Now it could go this way, it could go straight up, it can go to the side. You do whatever you want to do. I'm just going to do that. It really doesn't matter. And I'm going to put a C on here. Okay, so ABC is what that wanted, is 4x. I always label my angle to the inside, like where the actual inner angle is. And then it says that CBF, so do I need to draw another one? CBF. CBF. See, I don't need to draw another little ray because it's already here. It's the same C with the B and a F. This one is 5x. Find x and find the measure of each angle. Well, if you have a straight line, how much does a straight line add up to? Well, it adds up to 180. So 4x plus 5x equals 180. And then we just math it out. So what is that? 9x equals 180. Divide by 9, divide by 9. X is that 20? All right, so we found x. X is 20. And then find the measure of each angle. Well, to do that, you just take your x and you plug it in. So 4 times 20, this is 80 degrees. And then 5 times 20, this is 100 degrees. And it's just to plug in and math it out, and that's how you finish out the problem. So just be careful in case you're asked to actually find the measure. You don't want to do half the work and forget to go plug it back in. Okay? All right, so that's really it for this week. There's going to be a lot of problems like this where you have to set it up and you have to know whether to let it equal 180 or let it equal 90 or even something else. And I hope it goes well for you. We'll see you later.